Intro. Welcome to our channel. Today, we're diving into a highly relevant topic in the field of artificial intelligence and machine learning, building a robust AI pipeline. Whether you're a budding data scientist, a machine learning engineer, or just an enthusiast keen on understanding how AI systems work, this discussion will guide you through the entire process, from data ingestion to model deployment in production-ready systems. We'll break this down into several key stages, highlighting best practices, tools, and methodologies you can use to construct an efficient AI pipeline. So, grab your notebook and let's get started. Section 1: Understanding the AI pipeline. First, let's define what we mean by an AI pipeline. An AI pipeline is a series of data processing steps that facilitate the creation, training, and deployment of machine learning models. At its core, an AI pipeline is about taking raw data and transforming it into a model that can make predictions or decisions based on unseen data. The pipeline typically consists of several stages, including data ingestion, data preprocessing, feature engineering, model training, evaluation, and deployment. Each stage of the pipeline plays a crucial role in ensuring that the final model is robust, efficient, and capable of delivering accurate results in real-time applications. Furthermore, a well-designed AI pipeline allows for better collaboration among team members, facilitates scalability, and ensures that models can be consistently updated and improved over time. Section 2: Data Ingestion. The first stage of our pipeline is data ingestion. This is the process of collecting and integrating data from various sources into a unified system where it can be processed and analyzed. Data can come from numerous sources, including databases, APIs, web scraping, IoT devices, and more. One key aspect to consider during data ingestion is the format and structure of the incoming data. Datasets might be structured, semi-structured, or unstructured. Structured data fits neatly into tables, like SQL databases, while semi-structured data includes formats like XML or JSON. Unstructured data, such as text documents or images, requires additional processing steps to extract useful information. When building your ingestion pipeline, choose the right tools that can help automate the data collection process. Tools like Apache Kafka, Apache NiFi, and AWS Glue can aid in streaming or batch data ingestion. They allow you to set up connectors that pull data from multiple sources automatically, making your pipeline more efficient and less prone to human error. Another important factor during data ingestion is ensuring data quality. Ingesting data without verifying its accuracy can lead to garbage in, garbage out scenarios. It's essential to establish data validation rules to check for consistency, completeness, and accuracy during this phase. Section 3: Data Preprocessing. Once your data is ingested, the next step is data preprocessing. This step is crucial as it prepares raw data for analysis and model training. Data preprocessing can include various tasks such as cleaning, normalizing, transforming, and splitting data. Data cleaning is the first task in preprocessing. This involves removing duplicates, handling missing values, and correcting inconsistencies in the dataset. For instance, if you're working with customer data, you might find instances where the same customer is recorded multiple times with slight variations in their names or addresses. You'll want to resolve these discrepancies to ensure your model is trained on accurate data. Normalization is another vital aspect of preprocessing, particularly when dealing with numerical data. Normalizing data helps to scale features to a similar range, which can significantly improve model performance. Techniques such as min-max scaling or z-score normalization can be applied, depending on the requirements of your model. Transforming data is another important preprocessing step. This could involve encoding categorical variables into numerical formats, creating interaction features, or conducting dimensionality reduction to simplify datasets. Tools like Pandas and Python can be invaluable during this stage, allowing for quick and efficient data manipulation. Lastly, after preprocessing your data, you'll want to split your dataset into training, validation, and test sets. This division ensures that your model can be trained on one subset of data while still being validated and tested on unseen data, which helps prevent overfitting. Section 4: Feature Engineering. Next, we move on to feature engineering, which is one of the most critical steps in the machine learning pipeline. Feature engineering involves selecting, modifying, or creating new features based on your raw data to improve model performance. High-quality features can make a significant difference in the effectiveness of your machine learning model. It requires a deep understanding of the domain you're working in and the problem you're trying to solve. For instance, if you're building a model to predict house prices, useful features might include the size of the house, number of bedrooms, and proximity to schools or public transport. Feature extraction techniques can also be employed, especially when dealing with unstructured data like text or images. For text data, techniques such as bag of words, TF-IDF, or word embeddings like Word2Vec or BERT can be used to convert text into a numerical format suitable for model training. In image processing, convolutional neural networks, CNNs, can automatically extract features from images. It's also essential to assess the importance of your features. Techniques like feature importance scoring or recursive feature elimination can help identify which features contribute the most to your model's predictions, allowing you to focus on the most impactful variables. Section 5, Model Training. After data pre-processing and feature engineering, the next stage is model training. This is where your machine learning model learns from the training data you've prepared. Depending on the problem at hand, you might choose different algorithms, such as linear regression, decision trees, support vector machines, or deep learning models. When training your model, consider hyperparameter tuning, which involves exploring different configurations of your model parameters to find the optimal settings that yield the best performance. Techniques like grid search or randomized search can help automate this process, allowing you to focus on other aspects of the pipeline. It's also vital to utilize cross-validation techniques during training. This strategy helps in assessing the model's performance and stability across different subsets of data, providing a more reliable evaluation than simply using a single training and validation set. Section 6, Model Evaluation. Once your model is trained, it's time for evaluation. This step involves assessing the model's performance using the validation set and various evaluation metrics. The choice of metrics depends on the specific use case. For instance, accuracy, precision, recall, and F1 score are common for classification problems, while mean squared error and R-squared are used for regression tasks. During evaluation, it's essential to look for overfitting or underfitting. Overfitting occurs when your model performs exceptionally well on the training data but poorly on unseen data, while underfitting indicates that your model is too simple to capture the underlying patterns in the data. Using techniques like regularization can help manage these issues. Another important consideration during model evaluation is interpretability. Understanding how your model makes decisions is crucial, particularly in sensitive applications such as healthcare or finance. Tools like SHAP Inline can help in interpreting complex models, allowing stakeholders to trust and further analyze the predictions made by the model. Section 7, Model Deployment. After evaluating and refining your model, the final stage of the AI pipeline is deployment. This step involves taking your trained model and making it available for use in a production environment. Deployment can be done in several ways, such as through REST APIs, cloud services, or even embedded systems, depending on the requirements of your application. It's essential to monitor your model's performance continuously after deployment. Real-world data can differ significantly from the training data, and your model may need adjustments to maintain accuracy. Establishing a feedback loop where the model can learn from new data is crucial for long-term success. Additionally, consider implementing A/B testing strategies to compare different models or versions in the production environment. This approach allows you to test changes incrementally and understand their impact on performance. Another critical aspect of deployment is ensuring scalability. As your user base grows, your model should be able to handle increased load without sacrificing performance. Tools like Docker and Kubernetes can help with containerization and orchestration, allowing for more robust and scalable deployments. Conclusion. We've covered a lot of ground today, from data ingestion to model deployment in production-ready systems. Building a robust AI pipeline is no small task, but by following these steps and best practices, you can create a system that is not only efficient but also reliable and capable of delivering valuable insights. Remember that the field of AI is continuously evolving, with new tools and techniques emerging regularly. Keeping up to date with the latest advancements will help you refine your pipeline further and adapt to the changing landscape. Thank you for joining us today. If you found this video helpful, please give it a thumbs up and subscribe for more content on AI and machine learning. We'd love to hear your thoughts or questions in the comments below. See you next time.